Hello, everyone. My name is Nathan, and I'm going to be talking a little bit about merging in Linux stable to your Android trees. I'm going to start off by talking about the Linux kernel process, just so that you can kind of get a feel of why this matters. And then I'm going to go ahead and talk about how to actually merge things in. And then I'm going to kind of give an example about how you might go about thinking about fixing conflicts that arise from doing this. So I'm on kernel.org here. This is where you're going to be fetching everything that that matters. Um, and so we have a couple different types of kernel trees. So I'm just going to start off with the first one, which is called mainline here. This is where all development happens. This is where companies like Intel, AMD, Google even contribute their fixes to the kernel. And as you can see, the latest version is 4.15 RC8. So the basic mainline development process is Linus Torvalds will take patches from all of his maintainers for 2 weeks. So for example, this latest cycle, he released 4.14. Next day, he's going to start taking patches from all of his maintainers. So they'll send him pull requests. These are commits, features, bug fixes that have been tested over the past couple of months, and they're ready to be merged in here. And then he'll release RC1. Then after that, he'll release RC2, RC3, RC4, usually releasing the final version around RC7 or RC8. So maintainers are allowed to throw features at him for those 2 weeks, and then after that, it's bug fixes only. Well, the thing about the mainline tree is that it's the development tree. Things are not always stable. They will get fixed, and once they are deemed stable, that is when a release happens, but it's not going to get released until then. Well, let's say that you're on 4.14, and there were regressions that happened at the end of the 4.14 cycle. How do you get fixes? You don't want to run the mainline kernels because those can oftentimes be unstable on your machines. That's where the concept of a stable kernel comes in. So what Greg Kroll-Hartman will do, he's the main stable maintainer. He'll go ahead and fork off Linus's tree. So when 4.14 was released, he forked it off, and then he's going to start releasing 4.14.1, 4.14.2, so on and so forth. As you can see, the latest stable kernel is up to 4.14.13. The rules for stable are that it has to be in Linus's tree first. This is the most important rule. The reason being is that you don't want your trees to diverge. You don't want to have a fix that goes into 4.14 that then prevents people from upgrading to 4.15. The other couple of rules to keep it sane, basically, is it has to be 100 lines or less usually. There are exceptions to this, like self-contained drivers will oftentimes have patches that are larger than this if they're part of a series to bring in a lot of good fixes. The SCSI driver had this recently in 4.4, I believe. And it has to be a real bug fix. It has to be something that could be triggered by people. It can't be any sort of theoretical condition. And that's pretty much it. And so that's what goes into the stable kernels. And then you have these long-term kernels, which are sometimes maintained by Greg, other times maintained by other people, like 3.16 and 3.2 are maintained by Ben Hutchins as part of his work for Debian. 4.1 is maintained by Sasha Levin. 3.10, before it was dropped most recently, was maintained by Willie Thoreau. So these other maintainers often will pick these up after Greg has dropped support for them for various reasons, whether it be their own work or they just wanted to help maintain this kernel for longer than they should have. You can actually see who maintains each kernel and how long they're going to be supported for on this page. And this also kind of gives a description of what each kernel means, which is what I kind of just explained. So as you can see here, the projected end of life is when these kernels are going to stop receiving updates. So most recently, 4.4 was actually announced to be supported for 6 years, primarily as a result of Google partnering with with Greg to maintain these kernels for so long due to Android devices. Android devices are always based on long-term kernels. Primarily the reason being that Qualcomm has a lot of code that is out of tree that is necessary for these devices to run. If this code was in mainline, we could potentially upgrade every time mainline had a new update, and it would actually be pretty easy because all of that code is then helped maintained by the community. As it stands right now, it is very hard to port forward that code and requires a lot of work on that part. Greg said in one of his most recent talks that that is changing. Qualcomm is trying to get more of their code in upstream, but it is going to be a long process. So until then, we're basically just going to be taking stable kernel updates. And on that note, a lot of Google or a lot of OEMs haven't been updating their kernels. For example, the 835 that released, a little under a year ago, initially shipped with a 4.21 kernel, missing a lot of fixes. I'll actually, when I switch over to my server here, I'll show you how many fixes were missing from that kernel. Thankfully, due to Greg pestering these companies, they are changing. So Google actually is the most prolific user of this. They shipped the Pixel 2 kernel with a 4.4.56 kernel. So they were actually 35 versions ahead of what the 821 or the 835 shipped with. So they got that far, and then with the latest Oreo release, they actually got to 4.4.88, which is really great. It's really awesome to see. Same thing happened with the Pixel kernel. So the 820 and the 821 shipped with a 318.31 kernel, and they're now seeing updates. So Google updated for Oreo, or the first Oreo release, they got to 318.52. And now they're up to 318.70. And so when the next version comes along, I'm sure that they will have a newer version, which is great. It really is great to see OEMs taking this seriously, because these fixes do matter. That's kind of a segue into the next topic. Why haven't developers been doing this before? If these fixes matter, because they do. In fact, Greg did a demo for kernel recipes this year that literally showed him crashing a Pixel phone from an untrusted app. This is with SE Linux. This is with all of Google's Defense in Depth. A simple app could crash the phone. Crashing, not that big of a deal, but these things could certainly be weaponized a little more and make big splashes. So why does this matter? It matters for just that reason. These are fixes that are relevant to the tree that they're going into. These are not huge backports. These aren't big additions. These aren't unstable additions. A lot of developers have built up this false narrative that these fixes are for drivers that we don't build, for things that don't matter, like other architectures. And while that is true, it doesn't mean that we shouldn't be taking these updates. Nobody runs the entire kernel. The kernel is massive. Nobody builds all of the drivers. Even your common distributions like Ubuntu, Red Hat, Fedora, Arch, all of these distros don't build all of the drivers. That doesn't mean that they shouldn't be taking the updates, because it's harder to sift through the updates and look for the fixes that you do need rather than just take them all. Because if you're merging in dead code into your tree, it doesn't matter. Git handles that perfectly fine. You shouldn't be getting conflicts on stuff that you're not touching. So on that note, let's go ahead and see kind of why this matters. So this is my Flash kernel tree for the Pixel 2. So Google shipped with, again, 4.488. We're now on 4.4.111. So this demo that I'm going to be showing you is we're going to be running into a conflict when merging in 4.4.112 RC1. So the stable kernels also get release candidates. Greg will usually push them out to his trees and then let them get reviewed for 2 days, and then he'll push them out to public. So why would we get conflicts? Like why would we get a conflict? A conflict basically means, or the way that Git works is through deltas. So it has a before and then an after snapshot. Well, when the before doesn't match the before that it has in its blob, it throws an error. It's like, okay, I was expecting this, you showed me this. So what Git's going to do is it's going to go ahead and find the common, it's going to find the common lines between the files, and then it's going to go ahead and give you the diff. It's going to give you what you have versus what it's expecting between the two common points. So let's go ahead and do that. So I actually have a script that's automatically going to run the update commands. I will go ahead and in the video description link my guide for doing this. It shows you all of the commands manually, and then I also have a script, a public version of this script to help people with this. So as we can see, we're on 4.4.111. It's going to be merging in 4.4.112 RC1, and it shows that we get a conflict in the DM driver. So the first thing you should always do is you should always see why you're getting a conflict. So sometimes you'll get a conflict because you already have the patch and there have been other additions to the file, and that means that you can just discard it. Another reason you might get a file is, like I just talked about, there's been a patch that's added that's changed something, and it's basically messing with your before picture, because again, Git works in deltas. So let's go ahead and see. So we can actually use the git diff command. We're going to specify that we're looking at our head commit. We want to see what the diff is between what we have in our tree, or we want to see the diff that we have in our tree, basically. So it looks like this part merged cleanly, which is good. But then this is the part that's throwing the error here. So this static unsigned long DM buff.io shrink count, this is common between the two files. We don't need to worry about that. These are the two sections that are conflicting. So we have this in our tree. It was expecting this to be the final product of the patch. So let's go ahead and actually find out what patch is causing this. So git log has this handy p flag that we can pass to it, which will give us the commit message as well as the final diff. So we're looking between 4.4.111 and the stable RC tree. So normally, if you're just merging in normal Linux stable tags, like let's say we were going from 4.4.110 to 4.4.111, then the first part of this would be 4.4.110, period, the 4.4.111. And that would give you the commits that were in 4.4.110, or that were in 4.4.111 since 4.4.110. And then we want to just specifically get it for the DM buff.io file. So we only want to know the changes for the specific file because that's the only file that we have a conflict in. So it's this fixed shrinker scans when the number to scan is less than the retained target. So we have the commit message. What's really nice about Linux stable commits is that the mainline hash is always in the commit message because, again, these are patches that are being backported from mainline. So we want to know what it is in mainline and then what it is here. And it actually looks like this is a patch that was designed for an Android device because, again, it is somebody from Google that was doing this test. Which is good. And so, as we can see here, this is the section that's causing everything to. So this is good. This didn't conflict in our original diff, but this is. So looks like we have all of these changes that don't matter. So because we have that function that was changed, let's go ahead and figure out why that commit. Like why we're getting a conflict. So we actually have this handy command called git blame. What git blame does is it tells you what was the last commit to specifically modify a file or a specific line in a file. So we're actually going to go ahead and git blame. So looks like the conflicting section, because again, this DM buff.io shrink count is common between the two common between the two branches, the one in our tree versus the stable branch. So we're going to look around this thing, and then we're going to specifically look in the driver's MD file. And so we're going to go ahead and run that blame, and then we're going to go ahead and get the specific lines here. So looking here, it looks like this line was last changed in 2011. That's probably not the relevant commit. Instead, it looks like it's this one, 2016. 4.4 came out in at the end of 2015, I believe. So this is something that's clearly been added since the initial release of 4.4. Now, we can look at a specific commit by running the command git show, and then I'm going to pass it this format flag. I want to see who added this commit. Was it Qualcomm? Was it Google? You always kind of want to look at who adds something, because that oftentimes tells you the context of why they added that. So as we can see, it was somebody from Google that added this. Tim Murray, I believe, works on the Pixel team. And okay, so it just looks like it's a bug fix. So the nice thing about Google commits is you can always tell Google adds a commit by this tag in the commit message. So this backport, what that means is that they took a commit from mainline and added it to, and then they added it to their own tree, but there were conflicts that they had to resolve. They basically had to do this process that we're doing right now. And so, as we can see, this is what changed that entire function. It deleted all of the stuff that it was expecting, here. So all of that is the stuff that got removed. So that's why we're getting a conflict. Well, okay, so now what do we do? Well, the first thing we probably want to do is we want to look and see when this was added. So this was added to mainline December 6th, so about a month and a half ago. Well, okay, so that probably means that because this commit is clearly in mainline because it has this backport tag. Because this commit was added in mainline and it was added in 2016, it probably means that this patch was modified in some way to make it work for the current 4.4 tree. The way we can verify that, the way we can verify that is we can go ahead and take the commit hash here, and we can just run a simple git show on it. We can just see what the patch looked like in mainline, because it is possible that that's the version that we need to take. We might not even need to do any adjustments to this patch. And so as we can see, that does look to be the case, because this struct, this struct DM buff.io client, this line is the same here. And this is the same as this line minus the access once. So spoiler alert, I've already done this resolution, and I can tell you that there was a trivial patch that was merged in mainline that changed this access once to read once. So what we can do is we can just simply take this patch, this version of the patch, and we can go ahead and just modify it so that instead of read once, we're using access once here and here. So that's exactly what we're going to do. So first off, we need to go ahead and get rid of the current changes to this file, this DM buff.io file. Because in order to apply patches, we need to have it be clean. So we're going to go ahead and reset it here, and then we're going to go ahead and just check it out. So then if we run git diff head, we should get nothing. Okay, great. So we're on a blank slate here. Well, the first thing we want to go ahead and do is with this mainline commit, let's go ahead and just generate a patch file. Because we're merging, we can't like cherry pick or we can't automatically add this commit in its form. We need to generate a patch file and then apply it to the file using getApply. So we're going to go ahead and we're going to format a patch. We only just want this one commit. And then we're going to go ahead and generate a patch file. Well, all right, let's go ahead and see what this looks like. I actually know that this is the only patch file I have here. Okay, cool. So this is just a normal get patch file. It has the before and after. and then we should be good. So I'm actually going to go ahead and use sed for this. You could just use a normal text editor, but I don't necessarily see a reason to. So we're going to take the read once of that, and we're going to go ahead and use access once instead. And then we'll just go ahead and feed it the patch file. And let's go ahead and just see what that patch file looks like now. So as we can see, it now uses access once instead of read once, which is exactly what we need it to do. Now, Git is really cool in the fact that it has its automatic patch. It has an automatic patch application function. So this 3 flag is just to make sure that I don't necessarily run into any weird errors when applying this. Sometimes Git, even though you might have a clean application, it will sometimes error. And so passing it this 3 flag signals that you want a 3-way merge, which is the standard for like cherry picking and stuff. So then we're just going to go ahead and feed it the patch file. And if it doesn't return any errors, it means that it applied successfully. So now if we run the git diff head command, we should see that we now have a clean resolution, which we do. So it's the same as the one in mainline. We just had to change that access once because we don't have the commit that changed that, which is great. And so now if we run git status, and I'll go ahead and just do the short one. Actually, I'll do the full one just so that you can see. So we now see that we have all of these files that are modified. So yes, we have some MIPS commits. We have some x86 commits. We have some, drivers necessarily that we don't use here. However, we can also see that this is all just going to merge in cleanly. We didn't have to do anything with it. The only thing we had to fix was a file that was actually relevant to us. A DM file that Google clearly cares about because they added fixes to it. And so now what we can do is we can just go ahead and finish up our merge. So I have a specific command that does this because I actually format my commit messages. Normally you would just run git merge continue. Again, keep in mind that this does also apply to cherry picking. I personally think that merging in is a little bit smarter because you don't necessarily see how many commits you're merging in. So we're going to go ahead and finish the merge, and let's actually see how many commits we just merged in. So we'll just go ahead and do one line. We're going to do from 44111 to the stable tree. Whoops, yes, Linux 4.4.y. And then we're just going to go ahead and get a word count. So we just merged in 72 patches, which we can also confirm here because I do that in my script. We just merged in 72 commits. We only had to fix one conflict. And now we don't even have to look at, we'd obviously want to build this. I'm not going to because that's going to take a little bit of time. But we now can see that I just merged in 72 commits in a matter of a fraction of a second. This process, without me explaining it, probably took me 2 or 3 minutes. And now I have 72 patches that may or may not be relevant to my tree, but I at least know that I have them and that I'm more stable, more secure, more up to date than I was before. Now, I mentioned that I would go ahead and show how many commits were missing before. So the difference between 4.4.21 and 4.4.111 is actually astronomical. So it is a lot of commits. Yeah, all over 4,000 commits. Even what Google has in their tree right now is still missing a significant amount of commits. So 1,100. Now you may be saying, well, if somebody like Google is already going to merge those into their tree, why would you do it ahead of time? Because I can. This is 1,100, almost 1,150 commits that I don't have, that I wouldn't have in my tree if I just waited for Google to do it. Because as of right now, Google is not doing this process in anything other than major Android revision updates. So like 8.0, 8.0.1, there might be 3 or 4 months in between theirs, in between those. In fact, 4.488 was the latest version when Google finished their their big kernel merge in September. It's January now. That's a difference of 3 months. There have been 1,150 commits since then. Just take them in your tree, do this process yourself, and you can always be sure that you're going to be more up to date than what your OEM can provide. That's basically it. That's all I have. Again, fixing conflicts is not necessarily an art that you can just pick up in 3 seconds. It's all about looking at the context. Why are you getting a commit? What commit caused the conflict? Was it something that Google added and you maybe just need to work around it? Was it something that Google or Qualcomm added from mainline and then you need to go get the mainline version of that patch? Sometimes Qualcomm or Google will fix bugs in a different way than mainline that may be actually better for the tree. I know that 3.18 had several USB patches that ended up causing a bunch of issues with mainline commits. And so you just had to take the Qualcomm versions of those. It's all about context, and yes, it can be difficult, but it can be difficult, but it is still worthwhile to do. That's pretty much all I had. If anybody has any questions, you can find me on XDA, Google+, Twitter. I'm on Telegram as well. I'll leave a link in the description that has a link to all of those on my website. Feel free to reach out to me. I'm more than happy to help people resolve these conflicts or help get through them. It really is important to do this with your own trees, and I want to make sure that everybody has the opportunity to do that. But feel free to reach out to me if you have any questions, and have a great day.